Welcome back again. Hello everyone. This is Mohammad Abdul Numan from Institute of Aeronautical Engineering. Currently in 8th semester. My TikTok topic is about innovative research perspectives in avionics systems panel. In this presentation, I am going to give a brief introduction about the topic and what are the advancements we have gained and what are the research perspectives we have achieved in our avionics regarding the research and development of the aviation industry. Before going to start, I'm going to tell about what is the avionic system panel. Where does his arrival came? It is a technical operation panel of the IEEE Aerospace and Electronic Systems Society. The panel addresses contemporary issues in avionics systems research, design, test, and certification for civil and military applications. The area of focus includes communication, command and control, navigation, surveillance, and unmanned air vehicle management, and space systems. It also monitors, analyzes, and supports industry and government activities relevant to its technical focus, such as National Aeronautics and Space Administration, which is NASA, and UAS systems, traffic management, and AFCA, the next generation air transport systems, and certain programs that include. There are some of the goals of this panel, which includes are to promote and support collaborative research initiatives in the domain of avionics. It all to promote and support collaborative research in the domain of UAS. To promote and support high quality IEEE publications in the domain of avionics. To promote and support educational activities in the domain of avionics. To sustain and oversee the program of IEEE Digital Avionics System Conference, and there are many more to come. It will take a long to explain all this motive behind this avionics system panel. Coming to the introduction, this presentation will explore the latest advancements in avionics systems. We will delve into cutting edge technologies and their potential impact on the aviation technology. First and foremost, activities in this panel we can say they are communication, navigation, and surveillance for air traffic management, avionics system integration and society, and multi domain avionics, and at last but not the least, automatic and autonomy. Coming to the air traffic management, it is a certification framework for integrated CNS and avionics system. Fault oriented and avionics design and integrated vehicle health management systems. Integration in all classes of airspace and unmanned air vehicles. Avionics for future space transport, space traffic management, and intelligence systems. The this panel has a leading role in the organization of some of the big configurations, which include ICNS. Evolution of avionics. The evolution of avionics has revolutionized the way aircraft operates, from traditional analog systems to modern digital interfaces. The aviation industry and witnesses a remarkable transformation. I'm going to highlight is key milestone and technology breakthrough. Coming to the analog systems, it started the avionics in the aircraft started mainly primarily for sole purpose of communication. It started in during the Second World War, where we have radios communication between the pilot and the ground control systems. Later on, we developed transmitters. Then we got advanced micro memory processing systems in that, and but last at last in the early 2000 we got VLSI technology. We will evolutionize the avionics in the aviation industry. Next generation navigation. Advancement in navigation system have paved the way for more precise and efficient flight operations. I will explore the integration of GPS, industrial navigation, and other emerging technology to enhance aircraft positioning and en route optimization. According to aviation market forecast, predicting the coronavirus disease pandemic, the traffic was expected to double by 2023 and quadruple by 2050. Within the same time, it was also expected that aviation could contribute 6% of all human induced climate change, while half of all air traffic would take off, land, or transit through the Asia Pacific. While finalizing this article, the COVID pandemic has led to a reduction in global air traffic in the order of 90%. However, once the emergency is resolved, it is reasonable to assume that both domestic and international air travel will return to pre pandemic levels. If these assumptions prove correct, the market forecast may be a bit delayed, but both are still acceptable in long term. Enhanced communication system. Modern avionics are characterized by sophisticated communications that enable seamless connectivity between aircraft and ground stations. I will discuss the latest develop in data link technology and the impact on air traffic management. In response in these challenges, modern avionics systems are becoming cyber physical with software and hardware components seamlessly integrated towards performing highly automated tasks. These tasks are progressively more demanding and distributed among multiple platforms. While research trends elicit the introduction of AI, fault tolerance architectures, and adaptable to support the development of trusted autonomous systems. Safety and reliability. Ensuring the safety of the and reliability of avionics system is paramount in the aviation industry. From redundancy design to fault tolerant architectures, I will examine the strategies employed to enhance the integrity and resilience of aircraft electronics, which means the continuous growth of civil air transportation and widespread adoption of UAS system for new and traditional role poses a significant challenges to the aviation community, as the current onboard and ground-based system will not ensure the desired levels of safety, efficiency, and environmental sustainability in future airspace operation. As a consequence, several large-scale R&D initiatives were launched over the last 2 decades. Current programs are investigating the most promising technology and operation improvements to enhance the level of safety, capacity, efficiency, and environmental sustainability associated with current and likely future transport in a holistic manner by improving the design, manufacturing, and operations of the aircraft. Coming to collaborative research initiative, it plays a pivotal role in driving innovation and fostering cross-disciplinary advancements in avionics system. I will show notable partnership and industry academic collaboration that are propelling the field forward. Collaborative planning involves the creation of new services and the redistribution of current functions to key players such as airline operation centers and avionics systems in order to improve the efficiency and safety of the system as a whole. In summary, I can say that advances identified by the major modernization program around the world that includes role shifting, high level of collaborative decision making, dynamic airspace management, improved avionics and ATM systems. In order to introduce these innovative concepts and ultimately progress along the planned evolutionary pathways, a new number of technologies can be considered an essential in avionics. And the most important topic of this presentation is integration of AI and machine learning. The integration of AI and machine learning algorithm is reshaping avionics systems, enabling predictive maintenance, autonomous decision making, and adaptive control, which I have explained before. The main goal of the avionics system panel in the first is to provide global strategic guidelines for the evolution of the air navigation system through the promotion of investment in innovation by means of R&D activities and the alignment of regional R&D programs. Second is to support the global technical level implementation by ensuring the foundation, facilitating the evolution of the framework and optimization of air navigation resources with the performance based decision making methods. Now, the challenges and opportunities faced by the avionics system panels include the rapid evolution of avionics system presents both challenges and opportunities. I'll address the complexities associated with system integration, cybersecurity threats, and regulatory compliance. Also, highlighting the potential for innovation and growth, which means have become in avionics architectures have become increasingly more complex with widespread adoption of heterogeneous sensors network systems and the need for optimization algorithm to make its a cyber threat safety. We have validated and quality of the solutions implemented. Most of the automation being introduced is deterministic and lacks adaptability. In certain scenarios, it may end up by increasing rather than elevating the workload of human operations. Hence, instances of cognitive overload are not infrequent despite dealing with highly automated systems. Finally, I can conclude the kind of automation that is currently being adopted in complex systems is not deeply trusted by humans because it lacks sufficient transparency and integrity. The future trends include several emerging trends are poised to shape the future of avionics system from electric propulsion to advanced sensor technology. I will provide insights into anticipated developments and their implications for the aviation industry. Coming to the conclusion, I can proudly conclude that the future of avionics is characterized by unprecedented innovation and transformative potential. As we navigate towards an era of smarter, more connected aircraft, it is imperative to embrace a forward thinking mindset and collaborative approach to propel the industry to new heights. As per, I can conclude that as per the current scenario, large scale research and development initiatives are shaping the future of aviation and space operations. Avionics systems are becoming more cyber physical and progressively evolving into a variety of autonomous, intelligent, and closed loop human machines. I hope you understand my topic on the avionics system panel. How is working towards the more enhancement in a avionics technology. With this regards, this is Muhammad Abdul Numan signing off.